Okay, in this video I'm going to show you a simple example of how we again use this principle of the reduced triangle. Remember, the first step was this. We're going to multiply or divide all three sides by the same number to obtain a similar but simpler triangle. Then after we do that, we're going to solve for the missing side, whether we use the Pythagorean theorem or right away we can use the Pythagorean triples. And then, as the crucial thing, as remember the little baseball guy down here says, you need to convert back to the original problem. So that is the most crucial thing right there for sure, but let's do an example. So what you see is a right triangle, and in this right triangle you have one side to be 80, that's the hypotenuse, 60 is one leg, x is the other leg. So here's what we're doing. I have done this. I don't want to multiply 80 and I don't want to multiply 60 by something. The numbers are already big enough. But I want to obtain a similar, yet again simpler triangle to make this thing a little bit easier. So what am I going to do? Well, I'm going to divide. You can divide by anything, but 20 is a nice number for me because when I divide 80 by 20, it gives my hypotenuse now as 4 as my new converted side length. But I must be consistent and proportional, so let's divide this leg by 20. That gives me 3. I divide this x by 20. I'm going to make that a new expression of y, you'll see here in a little bit. So what I've created now is, as you see, can I do this? Sure, we'll do it. This guy here now is 4. This guy here now is 3. Ooh. So is that, ladies and gentlemen, a 3, 4, 5 Pythagorean triple? No. Don't fall into the trap. Because remember, if it's a triple, this 5 right here has to be the hypotenuse of the triangle. And you see the 4 is the hypotenuse. So you cannot use, you cannot use a Pythagorean triple. So what must you do? Well, use the Pythagorean theorem with the smaller numbers of 4, of 3, and y. So let's scoot over here. And now here you can see in this whole thing I'm using the Pythagorean theorem. So I put my 3 in there as the leg. I put my 4 in there as a hypotenuse. I now square that, and I get 9, I get 16. Subtract that from both sides, you can get y squared to be 7. Which means now when I square root this side and I square root this side, it gives me y is the square root of 7. So that is really through step number 2. I've made it simpler. I've used the Pythagorean theorem to find the missing side, but now the most crucial step, square root of 7 is not my final answer. I have to convert back. So back up to the triangle. Since I divided everything by 20, I divided everything by 20, I divided everything by 20, to convert back, I must then multiply my y value, this thing that I got for my non-converted side, weird, I have to multiply that, multiply it by 20 to make it work. And my final answer would just be 20 square root of 7. And using, guys, the principle of reduced triangle, that is wonderful. Notice you didn't need a calculator. There was no huge numbers to calculate. It didn't get to be nasty. You had to simplify a square root and break it down and break it down and break it down. Break it down. You just kind of converted it, simplified it, solved it, and then converted it back. It's awesome. That principle of reduced triangle is tremendous. Now, if you're not sure what I mean, let's go underneath this triangle and check this out. Well, let's say that you didn't have any of this stuff. You just wanted to say straight up 80, and you wanted to say straight up 60, and you want to just use straight up x. There's nothing wrong with it. Here's what it looks like down here. Put it in the Pythagorean theorem. So you get 60 squared, you get 80 squared. It gives you 3,600 and 6,400. I don't know about you, but 4 squared and 3 squared is a little easier than 60 and 80 squared. So then when I subtract 3,600, that gives me 2,800. I take the square root of both sides. Now I'm looking at the square root of 2,800 you can see down here. What? So now I got to take the square root of 2,800 and break that up into two factors. Here they are. One's 400 and one's 7. Why'd you pick 400? Because that's the biggest perfect square. Did you know that? You could have got it, but it would have taken a lot of work to get there. So the square root of 400 is just 20, and then the square root of 7, whoops, I don't know what's there, not there. The square root of 7 is just the square root of 7. So I got the same answer. Now I was talking fast through that, and it seemed like it's the same amount of work. But no way. I would never want to do this. It's not wrong. It just takes a long time to do it that way. So another example, hope that helps, in using the principle of reduced triangle. We'll see you in class later.